Thank you all for joining us on our straight talk on curves, a deep dive into horizontal curve safety assessments. My name is Mark Shields. I'm a Quality Accounts Vice President of Sales and Marketing, here to introduce Erin Martineau, who is our VP of Internal Operations at QC. Having graduated with a Master of Science in Computational Mathematics, Erin oversees QC's internal operations team with precision and expertise. With a keen eye for detail, Erin guides her team through every stage of video data processing, quality assurance and quality control, and data delivery, ensuring seamless project execution. Her dedication to upholding stringent requirements and high quality standards ensures that all deliverables meet client expectations. As a leader at QC, Erin is responsible for collaborating closely with other department leaders to refine systems and workflows company-wide. Passionate about cultivating high-performing teams, Erin's commitment to excellence drives QC's success, leveraging her extensive experience and knowledge to tackle complex challenges and achieve optimal outcomes in every project. As we're going through this, if you have any questions, please drop them in the chat. We'll address them as soon as this wraps up. Erin, whenever you are ready, please take it away.
All right. Thanks, Mark, so much for the wonderfully flattering intro. I appreciate it. So today we're just going to be taking a deep dive into basically how QC has managed our horizontal curve safety assessments in the past. So we'll talk about a little bit about, the relationship it has to traffic safety. I'll show you a little bit about alternative methods. We ended up sort of combining two of them, and then some key takeaways that we learned through going through this. So the entire reason we do horizontal curve assessments is we know how dangerous curves are, and we know warning signs work to reduce crashes. So NHTSA is, I've seen a couple different numbers here, but NHTSA is saying that there are about 43,000 traffic fatalities in the U.S. in 2022. We know that about 25% of those are happening at curves on highways, and then 85% of fatal crashes on curves are running off the road because they're going too fast. Lots of reasons there, but we also know there's been several studies done that just show that chevron alignment signs actually work to reduce reduce crashes. So this is and it's a pretty cost-effective countermeasure when you get down to it. So let's dive in. So I know that there was just a new version of the MUTCD released at the end of 2023, and this sort of it starts back in 2009, back when that particular version of the MUTCD really was focused on horizontal curve safety. They established a compliance date where we said, okay, all bad signs need to go. We need to make sure we are consolidating the signs that we're using. We're using less confusing signs. We're using uniform signs and consistency to not confuse drivers and things like that. And then they did consolidate sections relating to horizontal alignments in general as well. They set a date saying that by the end of 2019 we need to make this happen. So here's kind of a look at some of the signs. I sort of went over this already. It was focused on consistent usage of a few signs, providing better driver communications rather than doing lots of supplemental things and kind of going with just lots of different signing options. So rather than giving a lot of options, they really gave some good guidance and requirements there. And then, like I said before, they limited the set of signs that were applicable for for these places. And so just sort of in summary, they provided a lot of guidance regarding placement, sign usage. They did provide a nice standard for requirements for utilizing those curve signs. It was based on the differential in the regular speed limit and then the recommended advisory speed. This table, if you go to the most recent version of the MUTCD, the table is actually table 2C-4 now, if you want to take a look at it. So I went through the new MUTCD, actually a couple of us did, and looked through to see if the 2009 regulation and the 2023 regulation had any differences, or are there any new recommendations. There were a couple little things based on, sign type was updated slightly. We added some verbiage for exit ramps. We are able to, I know you've probably heard a lot about not just using the 85th percentile when you're determining regular speed limits. They're recommending that you take into account more data than that. But as it relates to horizontal curve assessments, it remains pretty much unchanged. So why might you need a curve assessment in the first place? And so I kind of wanted to focus on this part, because if you didn't do a curve assessment, or if you haven't had one done in the last 10 years or so, you may have some problems with the existing data. You may not even know what method was used to determine the advisory speed. I've got a lot of issues listed here. You may have changes in roadway conditions, a lack of uniformity. And here's I see this number 5 a lot. The preponderance of inaccurate or too low, advisory speeds that are just too low, causes drivers to disrespect them. And so they just blow, they think I don't need to go this slow. And so they go too fast. And then that's, they have a wreck. And then there may be you may be in a place where there's not really any existing data on your current sign inventory or your roadway geometry. And it makes it really possible, or impossible. Did I say possible? I don't know. It makes it impossible to really show that, hey, I'm conforming with best practices here. So a little bit about curve assessment in general. Regardless of, there's several methods out there that you could use to gather the curve assessment data. But regardless of the method you use, you're really looking at 6 key elements here. You're considering the roadway geometry, and that's a big word that I'll talk about in just a second, because there's a lot of things that go into that. You need to know the speed limit of the roadway. You're going to need to calculate the advisory speed. You need to know what signs are there in the first place. What regulatory parameters exist around, for the agency, for the area, and then you need to know, well, what are the proposed signs based on the roadway geometry and all that good stuff. If we focus in on the roadway geometry, it contains its own set of elements for describing the curve. So from these, we just use the vehicle speed and lateral friction to produce the recommended advisory speed for the curve. That's just basically it. We use math. I don't know what else to say there. So a little bit about the available methods. There are 6 recognized methods according to the FHWA. I looked this up. I haven't found anything new out there that they're saying, yeah, this is good, let's do this. since that 2011 paper. But we have the direct method where you're going out into the field and you're taking field measurements of traffic speeds. It's kind of like a spot speed study almost on the curve, but you have to be standing at a certain place in the curve and you've got to make sure your technicians are doing it correctly. There's the compass method where you're using a digital compass and a measurement tool for measuring, the distance that you've traveled. There's the GPS method where you're using a GPS receiver and some software to determine the road geometry. There's the design method where you basically do an analysis of the road geometry just from the plans you already have. You don't go out into the field at all. There's the BBI method. We've all heard of the ball bank indicator method. You do field driving tests around the curves and you get the speedometer readings, the BBI readings, and calculate the recommended advisory speed after the fact. And then there's the accelerometer method where you do field driving tests with an electronic accelerometer and a GPS receiver. So I pulled this from the FHWA paper. I thought they had a really nice chart about the advantages and disadvantages of each of these methods. Some, if you've got a really small study, maybe some would be better than others. If you've got a really big area that you need to do a study on, it's some just don't work. For example, the compass method, you really only need to use that on low volume roads because you're going to be stopping and measuring a whole lot. And it's just going to take forever. Some need 2 people in the car, some need 1. Some are really, really expensive, which this kind of isn't in there. But it was really interesting going back and looking through all of these. And in fact, KYTC performed a case study back in 2016 that investigated some of these methods, and they found that, most work well and they're accurate, but some of them required some level of subjectivity, and they've all varied widely in terms of cost and time and safety. And so the big key takeaway there is that what is necessary is a data collection system with report automation and then having a good plan for data management, because there is a whole lot of it. So here's what we ended up doing. And I decided to go back to this. The method that QC uses is we sort of combine the GPS and the BBI methods together. And I'll talk about a little bit about all of that. But what we were able to do was kind of get rid of a lot of the disadvantages associated with just picking one method over another. And for example, the BBI method requires 2 people during test runs. But because we were able to combine it with the GPS method and using an electronic ball bank indicator that had a GPS built into it, we kind of came up with our own little system that let us have 1 driver, so we cut down on human resource cost to do it. So this is kind of the approach that we have taken for the last, I don't know, over 8 years that we've been doing this. And so we're just going to share a little bit about that with you guys. So horizontal curve data collection system in general. So here's what an activity breakdown looks like in terms of who is responsible for what. So every curve assessment project has 3 major players. We have the transportation agency. We have, they are the ones that need the study done. They have the GIS data. They have other framework data. They may have existing road geometry or sign information, but maybe it's old, or maybe they need it looked at, what have you. And then they also are the ones that have a plan for utilizing the project output in some sort of sign maintenance program. Additionally, I'm going to hop over here to the right. We have the device or system manufacturer. So if you hop straight to the manufacturer, we have the people that make the equipment. They do a really good job at figuring out the best ways to make really good pieces of equipment that collect for road geometry, sign inventory, any other assets you're looking at. They make software to assist with report generation. They give you a database, and they provide a DVA for you. But the sort of the integrator here is your data collector or your engineering consultant. You still need people to do the study. And having good, having people trained that know how to use this equipment really well is a really key factor here. So we're the people, this QC, this, that's sort of where I live. We're the people that are using the software for the project management. We're doing the quality control on the data and making sure you get good data because we've done it over and over and over again. We've developed some good systems for doing it. And then we go through and actually produce the reports and the studies for you at the when we're done. So here's sort of this isn't super perfect, but this will work for me. It's sort of an overview of what the geodatabase structure looks like and how they talk to each other. So from the agency, we receive a whole lot of GIS data. We get the road network and mileposts and road segments. We break everything down into road segments here. We get posted speeds if you have them. We know, we get the ramp locations, existing curve data, sign inventory, and basically we funnel all of that and we make our own kind of geodatabase project management system. So we get all this good stuff, and for every single project we do, we create a turnkey project management system that is specific to that project because everybody's got different requirements, different needs, different things, reasons they're doing the project. What they're interested in. So obviously our deliverables, our processes, our QA procedures are going to be tailored specifically to that need. We use things like, cloud file storage management systems. We have our own project management architecture. We use ArcGIS Pro and project maps. We use AGOL maps. And all of this is used to manage the scope and the schedule, the delivery requirements, and then we also monitor our performance throughout using all of those systems. And then there are three major tools. I kind of like to think of these as tools and techniques that we use to create the reports. So the first major thing that has to happen, I'll talk a little bit more in detail about this, but the first thing we have to do is manage route planning, and so we've got a database for that. We push the maps from the network or from the road network into Basecamp. This provides our driving routes. This allows us to generate files for our drivers. Cars is what, and I will again talk about cars in a minute. We have our curve data management database. We import the mile markers from the agency. This is where our raw GPS and BBI data gets uploaded to. They've got a fantastic web portal for managing all of this data. And then within that, that's where we do our curve analysis and reporting. And then if a sign inventory is warranted for the specific project, we have another database where we import the road network. if, we import the agency sign type database, and then this is where we're able to go through and actually log and record a sign inventory. And then all of that beautiful data, this is kind of where these bottom two is, we spend a whole lot of time working in and going through and tracking, or these three really. And then once all of that is done, we can produce these beautiful curve advisory reports, proposed signs, and then an inventory of the existing signs for the agency. So let's talk about data collection. We have a nice little in-vehicle picture here, and that's kind of the setup. You have this little yellow box here. That's the Riker RDS7 GPS Pro, which is an electronic ball bank indicator. I'll get into it in a second. And then we either have a tablet or a laptop would work fine too. And that's kind of all you need. If you're doing a sign inventory as well, right next to this, maybe on this side or on this side, you might see a GoPro camera. And that's the other thing that just isn't here currently, but the technologies we use just to sort of actually do the data collection. We use GIS reference maps. We use Garmin navigation systems. I forgot about the Garmin. I didn't mention the Garmin. It's also here. It sits right here. It's not pictured either. We have the Riker system. We have a tablet. We have a driver log form. They can use the computer to fill that out. And then we have the camera. Change slides, please. Okay, here we go. Let's talk about routing. The GIS reference map, Garmin navigation system. So we can kind of break the reasons we have these things down into three major categories. So the first thing we do when we get all of the data is we start routing. Routing is our first major task. So we create a routing reference map. Back in, oh dear, what year was it? 2019. We've done lots of just total states like this, but we did New York. And New York had some pretty specific areas that they wanted covered first. And so how we began routing was really dictated by client preference. And so that's how we did it. So we pulled the network in, all the mile marker data, all of the roadway network data into GIS first. And so this is just a picture of our routing reference map. It basically serves to track our routing process. Not only does it provide us with a way to verify that we're providing comprehensive coverage, we're getting everything, but it helps us also coordinate with all of the project stakeholders, including New York State DOT, ensuring we're getting those priority routes areas mapped and driven first so that we can get that data to them as quickly as possible. It helps us coordinate our routing team. We have multiple people doing routing on big projects like this because we can knock them out really fast. We've got a whole team of people that are really good at this. So this helps us coordinate our routing team so that we don't have people routing the same areas. Because that's just waste, right? It helps us schedule our drivers after the routes are created, what's been done, what hasn't done. This is where we would track construction, if construction exists, or plan resurveying efforts if we needed to do that. We need to do redrives. So to actually design a route, that's just, so we used ArcGIS to sort of track our progress, monitor progress. But to actually design a route, we use Basecamp for that. So we convert the agency's road network shapefile into GPS routes of little mile segments. Basecamp allows you to estimate driving times so that we're able to schedule driving shifts with safe limits on, resting hours. We don't want them driving and driving and driving and driving without, sleeping between there, and then that wouldn't be safe. So the routes are saved into cloud storage, and then they are distributed to the field technicians for download when they go drive a route. So when a driver finishes a route, they log the route. That's what part of the reason they use the tablet. They notice any device anomalies, they note any construction, road obstructions, other miscellaneous notes, anything odd that happened during the field. My camera overheated, whatever. And so all of that log data is then transferred back to the GIS database that I mentioned before, and we're able to plan routing. And so this is a nice picture of that same area I was talking about that had been routed. So this has been routed, and it shows us how big each. And these are separate routes, and we labeled them based on preference. I believe the client wanted, a certain areas done first. So here we go. Okay, so that's a little bit about how routing works. Let's get into how we actually collect the curve data. So the Curve Advisory Reporting Service, or CARS for short, was developed by RER Inc. They've been doing, Riker's a pretty big company. They've been around for a long time. They do lots of ball bank indicator stuff. They've been in the game for several years. But this specific device was developed specifically for this purpose. So their system is comprised of three main components. They have an integrated inclinometer and GPS that is mounted to the dashboard of the vehicle. It collects and records data continuously throughout your trip. It records time-stamped raw GPS and BBI data in real time as you're going. The second part of the system is a tablet application that helps you set it up. It's kind of how you send your data to the cloud. And the third thing is the cloud portal that is super cool, and I will talk about it in a minute. Setup is pretty simple. Takes about 10 minutes. All you have to do is a quick calibration of the inclinometer, and then you do another one to verify that the device is level relative to the vehicle axles. And then you're good to go. Garmin navigation setup's also really quick. You pull and download your assigned routes. You pull those files to your tablet, and then you push them to your Garmin device. And then you turn your camera on. And something I didn't mention here is, let's just stay here. Something I didn't we don't have pictured is the SD card management. Usually if you're using a GoPro or any kind of dash cam, you're dealing with managing just lots and lots and lots of SD cards. It's kind of hard, and they're usually micro SD cards, and it's kind of hard to get an inventory on those bad boys. So we had to come up with a whole system for managing that as well. So that's kind of like a fourth database that we used to manage our stuff. So I promised I'd talk about the CARS portal. So here it is. So after the driver drives his route, he logs his route, and then he uploads his data to this cloud portal. And And what this wonderful cloud portal allows us to do is it uses a Google Maps API for just to visualize the data. And those are all the data points that it pulled here. We use a polygon tool to identify the point of curvature and the point of tangency for each curve. So I will say our folks go through quite a bit of training to do this accurately. So that's fun. But I highly recommend getting good training when you go to do this kind of stuff. And then it provides goodness of fit statistics to check the GPS quality, to show if the route that was run, was a successful run or not. There's lots of different types of curves, all that good stuff. Here's a loop ramp data example where we have modeled data in blue. That's sort of what the computer thinks the curve looks like, and it did a pretty good job here. The mile marker data, so everything's in different layers, right? The mile marker data is in red. It shows us, where we are. So the mile marker data helps us talk about where the curves start and stop. This kind of gives us a language and a frame of reference for talking about them. And then the GPS-BBI data is the green stuff. And then it kind of turns yellow once we model the curve. The model produces information about the curve radius, the curve length, the deflection angle, the curve grade, all that good stuff. Each curve is, so once we process the curve, each processed curve gets a safe curve speed analysis report. Now, typically QC will do this looks like we did 4 runs. Usually we do 3 or so runs in each direction, just to make sure we're getting really good GPS fit. So each curve gets this nice report. It tells you the lateral friction limit degree that was used to calculate the recommended advisory speed, and all that comes from the MUTCD guidelines. Gives you a grade for the curve, deflection angle, all of that is just done automatically. And you don't have to use an Excel file you downloaded from FHWA and bang your head against the wall, because like I did just recently, because it wasn't working. I couldn't get the macros to work. But GPS fit is in here as well. So what will happen is cars will choose the pass with the best GPS fit. And that's how our recommended advisory speeds are determined here. Now, we see here that the posted speed in and around this curve was 35 miles an hour. The recommended advisory speed was 20 miles an hour for both directions. And so this is a differential of 15 miles an hour. And so you would want to go and look, and it's probable that you're going to have either a required or strongly recommended signage in this area. So now that was one curve, right? That would be a whole lot for your entire system. So it also produces a nice summary report. We like to call it the HCAR for short. The summary report just gives you just the base data for the curve, what direction, travel, lat long, the recommended advisory speeds, just, very, very high level data. And then it's not in the picture, again, the GoPro and the SD card, but if an agency does not have a sign inventory or would like an updated sign inventory, it's really easy to collect while we're doing the curve analysis. This is a nice add-on project because it's not really hard to do, because we just stick a camera up there and we take the GPS from the camera, and the video from the camera, and all of that goes into SignProx. And so SignProx is a great program developed by Eric Green at is it University of Kentucky? I think it is the University of Kentucky. Eric built this to work with GoPro video. And this is it's sort of a database and sign logger program that will allow you to collect signs along the roadway and then map them onto a database. So the little red point, if I had a video here, I'd show you as you're driving along, the little red point moves, and you can tell that this is his route. And as we collect signs, or as we see signs come up in the picture, we can say, hey, I need to add a sign assembly. There's something there. And so you add information about the sign assembly. There's a lot here you can add. You can add different types here. Whether the assembly is damaged or not, any comments, it automatically takes a picture wherever you pause the video. You've got great GPS data. My favorite feature here is going straight to Street View. It's just gorgeous. You can just drop right down into Street View and say, well, what happened? You know, if you've got something kind of squirrely going on, this is my favorite button. If Eric is on this call, thank you, Eric. And then after you add the sign assembly data, you then go add information about the sign, because you know a sign assembly can have lots of signs on it. We receive sign information about what signs the agency, you know, has, you know, their current inventory, all that good stuff. Or we can kind of have the basics, you know, the basic MUTCD signs here, and we add information about the sign, which direction are we going in, you know, because we got to make a pass in both directions. And then whether the sign is damaged, if there's any special sign text or any notes on it, we add that. And that produces a nice map for us. And eventually we have a sign assembly report here with route information. So this is how it gets connected back to the mile marker data and the segment data for the client. And then we have a sign detail report. Each sign is connected back to an assembly in this case. So obviously quality control is a big deal to us. It's in our name. It's what we do. But so first, we can just talk about the curves first. First, we do a visual review of all of the processed curves. We really focus on type 2 errors, the false negatives. Did we miss any curves along the route? Not so worried about did we get too many curves, because it's probably likely that the recommended advisory speed's not going to say you need a sign anyway. But so we really focus in on the type 2 errors. Did we get everything? For signs, we do a random sampling of 10% of the signs along, of the whole data, and we check for both type 1, so the false positives, and type 2 errors, just to verify for data accuracy. These are people doing this, people that are trained really well, but so, you know, you kind of take that into consideration as well. It's like, okay, this person is missing signs, so they need to be retrained, they need to slow down, and we need to totally go back through this. Or you know, this person knows what they're doing, they're good. We also have an automated data flagging system that we programmed flags into the system just to automatically find anomalies that could point to different sorts of issues within any of our processes or our calculations. Maybe it's data accuracy, maybe it's network completion, requirements specific to the agency. Maybe it's an error in field collection. So we do have a list of things we do for once we generate both the curve reports and the sign inventory data. That sort of outputs a list of segments and curves and signs and that get reviewed. And then we either reject them and resurvey, or we accept them. So as you can imagine, this is just a lot of data. Here's just some stats. BBI readings, we get BBI readings with the system every 0.05 seconds. GPS readings every 0.3 seconds. And so in one day of driving, we've got over 500,000 data points. So we really don't want to have to go do curve assessment calculations and try to figure out what the recommended advisory speed is by hand for each curve. You really want to find a nice way to automate this. Also, having a geodatabase with data session is basically a data file. What pass it is, what curve it is, other sign identifiers. What this means is name your files appropriately. It will help. So with any, this is a cloud database, and with any cloud database system, you end up playing a game of how big can my files be, and this thing still function optimally. And so you end up playing sort of an optimization game, because the amount of data can just become overwhelming. And so something we found through this is to associate our data sessions with road segments to facilitate tracking and evaluation. So kind of like I said up there, like name your files appropriately. And 1 hour cars data sessions provide satisfactory computational efficiency without making data session management difficult. So 1 hour was the sweet spot for us. So the major takeaway here, for how am I doing on time, Mark? 2:45. All right. Major takeaway here was something I wanted to highlight was the way to make this cost effective, if you are an agency, if you're really wanting to look into this, is do a lot of curves at one time as much as possible. Do a big area. That's sort of the main thing here, because with any project, there's an associated implementation cost. Like there's a spin up cost. You're kind of reinventing the wheel for every little bitty thing, even though you might be the best systemized agency in the country, but there's still that that waste that happens. So try to my recommendation is do a big study, because that upfront cost becomes such a small percentage of it when you spread it across a big roadway network. Another really, really big thing that we learned was that providing mile marker data from the very beginning, from the agency to cars, was an absolute just game changer, because we ended up having this naming. I know I've mentioned that a few times, but be strategic about your file naming, I guess, is long story short. Communication, anytime you're working with different entities, whether it's the people that produce the tools that you use to get your project done, whether it's the data collector, what, any communication among stakeholders of your project. Communication's huge. So knowing construction schedules was so helpful to us to manage, to just route around them. We didn't have to go back. We didn't have to redo work. Prioritization of data collection schedules. Oh, I said that. Sorry. Having a common understanding. This kind of goes back. This again goes back to that communication piece. Having a common understanding of what the deliverables are, what the formats are going to look like. This interdepartmental communication, I think that's just super key. Understanding who is doing what, and are we redriving for video? Are we redriving for curve data? Are we redriving because somebody forgot to do the whole route, or we got confused, or what have you? There's just stuff that happens. Really understanding that, and each different task subgroup is really, needs to be communicating with each other so that we don't redo work. So there are times that you're going to have GPS signal issues. It happens. You're going to have them in tunnels or high rock faces. It doesn't happen very often, but it does happen. And the best practice, kind of what we did, is we revert back to BBI, and sign as winding road. Understanding automation and customization. Generating proposed signs for reversed curves, generating report special statistics like max elevation. I think really, this is, again, goes back to that communication piece. Are we, what's the protocol for doing X, Y, Z? What does the agency prefer? What happens if this happens? So just really, really getting into those special questions there. And that's it.
Thank you, Erin. I will take questions through the chat. We do have one currently. Which ASP do you use from the curve report from the 3 runs? Is it the one highlighted in green?
Yes.
Yes.
That was the best fit. We used the best fit curve or run.
Are agencies making your results available to the public?
I don't know.
Yeah, that I'm not sure about.
I think that's maybe a question for Jay, might know that, or if there are any agencies on here that have done this.
That's so far. Any other questions from anybody? You can put them in the Q&A or drop them in the chat. Jay said it depends on the agency.
Okay.
That is it so far. We'll stick around for another couple of minutes in case anybody has any follow-up questions, but thank you so much for attending. Really appreciate it. We did record the presentation, so we'll post a link to it and send it out within the next couple of days. Thank you so much for attending. Do all of your locations provide the curve assessment? Assuming by that, do they mean office locations?
Yeah, yes, we will do, I guess, if that is what we are. Yes, okay. Lynn, is that Lynn? Lynn says yes. Yes, absolutely. We'll do it. We'll do it wherever.
Yeah, we're nationwide.
Yeah. And beyond. Jay says
yeah.
anywhere.
International too.
Mars even, maybe. Maybe not.